Good morning, one and all. Our project is design and analysis of multi-story residential building in black cotton soil using Staad. Our project members are Vikram, Girish, and me, myself, Raghunath Kumar. Our project is done at Company Unitech Alliance BBB initiative. Abstract. The process of structural planning and design requires not only imagination and conceptual thinking but also sound knowledge of science of structural engineering. Objective of the project. The main objective of the project is to plan, design and analysis of a residential building. Design residential building should be analyzed in Staad software. Aim of the project to increase the standard of living and luxuriousness. Introduction. Residential building and houses falls under the category 4 as per IS 875 Part 2. Based on the above consideration, we have to construct the residential building in Perambur. Then a multi-story is a building that has multiple floors above ground in the building. To land places. Excavation, layout and foundation is the next step. Excavation is a process of making trenches. Excavation is done by the JCB on the hardly places. Black cotton soil. Black cotton soil with a wide range of challenges associated with the construction at sites with black cotton soil. Physical chemical properties of black cotton soil. pH value 8.9. Black cotton soil details maximum acid force 3461.32 kN. Literature review. Methodology. First methodology: site visit, literature review, data collected from site, concrete cube testing, M20, M30, preliminary design, analysis, Staad Pro, reinforcement design and atlas result and discussion. Study area: location of plot Perambur, size of plot 50 into 40 meter, number of stories G+6, height of the story 3.3 meter. Preliminary design, detailed design, slab, beam, column, staircase. Concrete testing as per 7 days strength, it is achieved as 26.99 Newton per mm square and 28 days strength 41.022 Newton per mm square. Compressive strength of concrete for M30 grade, achieved as 43.20 Newton per mm square for 7 days and 28 days 55.3 Newton per mm square. These are concrete testing cubes. This is a plan of beam numbering, slab numbering, column numeration, and our plan. Preliminary design of slab, size of room 4.955 into 3.350 meter, grade of concrete 20 Newton per mm square, FA 415 for continuous slab, span by effective depth equal to 35. Modification factor for tension reinforcement is equal to 0.8, therefore effective depth is equal to 120 mm. From table, design of beam, loads on the float slab, self weight of slab as calculated from the above dimensions, 2-way critical slab, 1-way critical. Design of column, FCK equal to 30 MPa and FI equal to 415 MPa. Load from slab per meter run of beam is 90.70 km. Assuming a 10% increase in load for self weight of column, total load equal to 255 kN. Top load. From the top load, we have calculated from the IS 875 Part 2 codebook. Load on bottom story is calculated as 1785 kN and effective cover equal to 40 mm, AG equal to 154,581.5 mm square. From the above calculation, we calculated as B equal to 2D, therefore D equal to 560 mm and 280 mm is equal to breadth. Provide 280 into 560 mm column. Staad Pro analysis. We have Staad Pro from the member load analysis and from the wind load, seismic forces, etc. This is a critical slab diagram column. These are Staad Pro diagrams which we have calculated. This is a main component of the building. This is a wind load analysis. This is wind load analysis in X and Y direction, in Z direction, in minus Z and plus Z direction. This is bending moment in X axis. This is a seismic analysis diagram. This is shear wall. Design of one-way slab. One-way slab. Slab we have connected a slab number SB13 as 4.955 into 2.220 meter. Total depth equal to 120 mm and factor load we have calculated as 10.5 kN per meter square as per IS 456 code books. Effective length of slab is equal to L plus D 2.22 plus 0.1 equal to 2.32 mm. Ultimate moment and shear is calculated from IS 456 ME equal to WL square by 8 and BU equal to WL by 2. Check for intent the depth is safe, hence the structure remains safe. Main reinforcement. Main reinforcement is provided from the table 2 of SB16 by ME by BD square by calculating the graph value and provided the spacing. Check for shear. Check for shear is calculated from IS 456 codebook with the help of P equal to calculated from the chart and hence the structure remains safe with the shear. Design of two-way slab. The critical slab we have taken as two-way slab, shorter side clear span plus effective depth 3.35 and aspect ratio Ly by Lx is less than 2, hence the slab is designed to as two-way slab. This is our types of panels and moment considered as per table 26 of IS 456 2000. Check for shear B equal to WL by 2 by IS 456 2000 code book. Hence, a slab is shaped in chair. Design of beam. Design parameters longitudinal beam. Bending moment calculated from the Staad diagram, and assuming the design as per the codal provisions SP16 and IS456. Number of bars is calculated as 2 numbers as per the distribution reinforcement, and for the main reinforcement 4 numbers. From table 19 of IS 456 2000, tau c equal to 0.67 Newton per mm square. Hence, we are providing spacing of vertical stirrups is equal to 160 mm, which is less than 300 mm. Transverse beam bending moment is calculated from the Staad diagram. Assuming the same as for the longitudinal beam, the same calculation is provided. Column design. Staircase is the rise of each step should be 150 mm to 160 mm. Number of rises is 20 numbers, and number of rises in each plate 10 numbers. Number of thread equal to 9 numbers. Pile foundation. Maximum axial force 3461.32 kN as per calculated from the IS codal provisions, and QU equal to QS plus QT. Ultimate load equal to skin friction, load from skin friction, and load from the tip of the pile. Hence, the design of pile group, number of piles we are going to design is 2 piles with a pile cap. Design of pile cap. Pile diameter 650. As a spacing of piles, HP equal to 2 into 650. Factor load we have calculated 5193 kN. Choosing approximate depth for pile cap is equal to formula from the IS 456 codebook. Conclusion. Preliminary design is carried out manually, and dimensions of slab, beam, and column are calculated using Staad Pro. Pile cap and pile foundation are designed to take the factor load as per. These are the references from Ramamrudam, Krishnaraja, and from the codebooks IS 456, IS 875, SP16, SP14. Thanking you.